So let's talk about inverse of a 2 by 2 matrix, which is actually fairly simple. Let A equal to, say, A, B, C, and D, a 2 by 2 matrix. So inverse of A inverse. So one thing, please remember, this is not A to the power of -1. This symbol is A inverse. Please remember that. So A inverse equals 1 over determinant of A times, now times another matrix, which is kind of rearranged. How is it rearranged? First of all, the A and D switch places. So the D comes here and A goes down there. And then we negate the diagonal B and C. So now I have minus B and minus C. Okay, so what is the determinant of A? We learned, so let's A inverse equals 1 over, if we figure out the determinant of A from the previous sessions, we have A times D minus B times C. Hope you remember that from past. Okay, so times the D minus B minus C and A. Now, let's have an example. So let matrix A equal 2, -3, 4, -1. And let's say that we want to find A inverse. Once again, this is not A to the -1. This is A inverse. That notation you need to memorize. So A inverse equals 1 over the determinant of A, which is 2 times -1 minus -3 times 4, that multiplied by -1, switch the 2 and -1, and negate the -3, so +3 and -4 in here. Okay, so A inverse sequence. A inverse equals, first of all, I have 1 over 2 minus 1 is -2. This gives me -12. Then I have a negative here, so +12, and then subtract 2. I get 1 over 10 times -1, 3, -4, 2. So I'm multiplying this scalar of 1 over 10 by the matrix. So let me go to the next page. And so multiplying this number by this, by this, by this, and by this. So A inverse equals 1 over 10 times -1 gives me -1 over 10. 1 over 10 times 3 gives me 3 over 10. 1 over 10 times -4 is -4 over 10. And 1 over 10 times 2 is 2 over 10. And I'm going to simplify, reduce this 2. So A inverse equal -1 over 10, 3 over 10, -2/5, and 1/5. So I found A inverse. And so suppose I want to check my work. Suppose I want to know, hey, is this really A inverse? Can I do that? Sure. How do I do that? I know that A times A inverse should give me the identity. So the matrix A is 2, -3, 4, -1 times the A inverse that we found it to be -1/10, 3/10, -2/5, and 1/5. Would that equal a 2x2 identity? So a 1 here, a 1 here on diagonal, and 0 everywhere else. So if I multiply A by A inverse, and the result is the identity, then I've done, good. So let's do multiply. Let me get, so this equals this multiplication. I'm going to take this and multiply, drop it and multiply. So 2 times -1/10 is -1/5. -3 times -2/6, -3 times -2/5 is +6/5. Now, this number goes and multiplied by this. I get 2 times 3/10 gives me 3/5. And -3 times 1/5 is -3/5. And let me just clear this. Now using this and this. Do the multiplication, I get -2/5 plus 2/5. And then using this, I get 6/5. -1 times 1/5 is -1/5. Okay. So notice that that equals put an equal sign here. -1/5 plus 6/5 is +5/5, which certainly is a 1. In here, -2/5 plus 2/5 is 0. In here, 3/5 minus 3/5 is 0. And here, 6/5 minus 1/5 is 5/5, which is a 1. So as you can see, I got the identity back. That means that I calculated the A inverse correctly. Okay, thanks.